So as a software engineer, I've been creating some large applications. However, recently I've been evaluating my software practices to see where I can streamline workflows and better manage my source code. To help me out on this journey, I'm really excited to say that Fabiola De La Cueva is here to share her experience and expertise about all things software management. So, hi Fab, thanks for joining.
Hi Tom.
Now, Fab is really well known in the LabVIEWverse, but for those who are quite new to the community, Fab, could you give us a quick introduction to yourself and what you've been doing at Delacor?
My name is Fabiola, but people call me Fab, as in fabulous and modest. I've been doing LabVIEW since 2000. I founded Delacor in 2006. So I left I used to work for I worked for National Instruments from 2000 to 2006. I left in 2006. I went to do my master's in electrical engineering, specializing in medical devices. I thought I was a hardware engineer. My husband was convinced that I was a software engineer, but I kept saying I was a hardware engineer. And when I got to my master's at the University of Texas, people started finding out that I knew LabVIEW, and they started hiring me to do LabVIEW. So there was two things happened with that, right? One is I found out that I was actually good at it, and the second thing I found out is that I loved it. I also found out that I really didn't know that much as I thought I knew from coming from an eye. So I had to start doing a lot of studying and researching.
Yeah.
So if we fast forward to now with Delacor, what I focus on, our team focuses on, is working with teams that either have gone from a lone programmer to a team, right? A single person doing LabVIEW, and now they have a team and they have no idea how to work for a team, or a team of LabVIEW programmers that didn't even call themselves LabVIEW programmers. They just were using LabVIEW because it was easy. And then once they realized that if you're solving complex problems, your solutions are going to be complex and you need to go a little bit of software engineering. So we come in and help them figure out what are the best practices for that team. Working different teams of different sizes of companies, working with startups versus working with established companies, working with tests and production versus just measurement, has given me different perspectives. And that's why when you posted on LinkedIn about, hey, I want to know how to do best, I'm like, well, there's really no one size fits all. There's different variables you have to take into consideration.
Yeah, and because of all of these trade-offs between things like patch project libraries, VIPs, DLLs, submodules, the grass for me is always greener if I try the other one. So I have all of this context switching, which is something I want to try and narrow down. So Fabiola is also LabVIEW architect, embedded systems architect, developer, professional instructor, LabVIEW champion, and all-round just LabVIEW role model. So I'm really pleased to have a Fab here.
Okay, now you're going to make me blush here.
So to kick things off then, I've had a few people say to me that your LabVIEW project, or your main project, should just be the glue or the facilitator to hold all of your source code modules together. How true do you think that is?
That's going to depend a lot, again, on how you're organizing things. If you have more of a plugin architecture where you have a main frame for where everything is running, right? Like for example, your phone uses the app as plugins. If you want to have a new functionality, you can download that new functionality, and you don't even have to restart the phone. Thing works, right? So if you are doing an application like that, an example of that would be a test sequencer or test environment, where you just say, hey, I just need a new oscilloscope, or I just need this new unit of test, and I only want to I don't want to have to reinstall the entire application. I just want to say, hey, go grab what I need for this new unit of test or for this new instrument. Then that's a really good example of where what you're saying is completely correct. You have a kind of a generic project, and then you have all these plugins that you can manage separately. If you're doing more of an application that's going to be standalone, and that whenever you're doing updates, you really need to redo the entire application, and there's multiple reasons for that. into PPLs, VI packages, PPLs. I mean, there's other things that you can do to manage your project in order, your main application. Let's divide that main application versus LabVIEW project. So you can have a main application that has a single project and then multiple projects to manage all the dependencies. Right.
So, a lot of these dependencies, both in Actor Framework, which I use a lot, and DQMH, which you're co-creator of, use all of these modules in libraries. So every module is its own library. One of the techniques which I've been trying to use is packing those libraries into PPLs or patch project libraries. So my first question is, what process do you go through to create these PPLs?
So there's a blog post, and I'm sure you're going to add to the comments, and then that's the blog post I sent to LinkedIn, where I describe the different processes. For packaging Actor Framework, you need to take the library that already contains the classes for Actor, and then add any other Actor classes that do ship with Actor Framework but are not made part of the main library. There's an excellent tutorial that Stefan Lemon did that shows all the steps on how to do this. So if you have, like, I think it's like a messenger actor, for example, the messenger actor is not part of the main actor library, so you would add that temporarily to the actor library and then build that into a PPL. And from then on, instead of inheriting your actors from the actor that ships with LabVIEW, you would be inheriting from the actor that's on the PPL. In DQMH, you have, again, go back to the size of your application. If your application has 2 or 3 DQMH modules, don't bother. Just call the code directly from the IDE, and it will be stuck into each one of your DQMH libraries when you build them into PPLs. If you start having a lot of modules, like some of my customers, 30, 40, 50 DQMH modules, then if you don't package DQMH library into a PPL, you are going to be copying that code now 50 times. So that starts to become a burden, right? Because you are carrying this extra code that you really don't need. So what you would do then is, and there's a video on that blog post that Matthias Bedor did, where he shows putting the DQMH library into a PPL, and then calling that PPL. Now, starting with 2019, that process is a lot easier because now you can go in both directions. Because one of the issues with packaging DQMH and then using DQMH is that a lot of the reason why people use DQMH is because of the scripting tools. So scripting would not work with the PPL version. So you would have to go back and forth for the scripting tools to work. Now, we are working right now on DQMH 5.0, and we're going to make it where you can specify what functions to use your enqueue from. So if your template is already pointing to the PPL, that should work. So that's on the works.
Nice. And for those of you who are using Actor Framework, who are experiencing a similar issue, there is a ini file token, which I'll again link below, to solve the same issue that Fab has just outlined.
Yeah.
When developing large projects then that have patch project libraries, are there any concerns you have about mixing and matching project libraries with patch project libraries?
One of the struggles that people have, anytime you want to manage your dependencies and package them, and what I call these codes, right? Having a distinction between code that is in development and code that is integrated and called by a thing. That doesn't have to be necessarily packaged. Like, it doesn't have to be in a BIP package. It doesn't have to be in a PPL. It can just be that you're using submodules and source code control, but you still need to decide which revision in that repository where you have the other code you're pointing to. So you have to have something that says, this is release code, this is ready to be used by others. In that other can be yourself, right? So one of the struggles that people have when you move from having everything in a single project and working everything in the same computer and single person is, but now if I start developing at the same time my modules and my main application, Now I have to do a lot of work where if I find a bug or if I find something that I need to add, I need to stop working on the main project, now go to the source project of my dependency there, build it, come back and integrate it. And that frustrates developers when they switch this mode of working, right? My advice is hang on it a little bit, because if you look at, if I could show you a graph of some of the largest projects that my customers have worked on, you would see that yes, at the beginning there's a lot of turn and there's a lot of going back and forward. But once the project is about 4 years old now, probably about less than half of the dependencies have not been rebuilt since 2015, right? So yeah, so if you go and ask that team in the middle of 2015, are you liking this mode of organizing the project? And they're going to be like pulling their hair because they're having to go back and forth, right?
Yeah.
When you come back after 2016 and it's like, oh, or even now, they're working at 2015 and that particular group uses packages, via packages, they don't use PPLs, they use packages. They haven't had to review any of those libraries since, like I said, 3 years ago. So that frustration has reduced a lot because now it's the way it should be. The things that when you're having to do changes, you're doing it in very particular sections, so you're not having to repeat the whole thing. So that I think that the main advice here is to be patient and you need to be convinced on why you're doing this to begin with, right? What are the advantages of going and separating? If you're convinced of that, just know it's going to be well at the beginning, but eventually it's going to pay off. And then you have to decide what your team is going to want to do. Are they going to want to do submodules? Are they going to want to do packages? Are they going to want to do PPL? Even timers would do separate examples and then use TCP/IP to communicate between them. That's before we have PPLs. I have not seen do that late, but that was
well, that leads into one of the sections I wanted to talk about actually, where using VIPM, VI Package Manager, there are several APIs that I've created, such as an XML parser, tree control, API error handler, etc. And all of those reuse libraries have very set requirements. I can create my unit tests, run them, and I can complete that module, build it, put it into the VILib, etc. However, there are lots of code reuse libraries which come as a result of a project that I'm working on. And so I end up with this constant context switching where I'm developing my source code for my project, switching back to code reuse libraries, building them, installing them. And then I realise I've forgotten a requirement, I have to put that in. And so your take-home advice here is just to be patient, see it through to the end, and then it will pay off.
Yeah, and then one of the things too is, I mean, you mentioned unit tests. If you are doing unit tests, if you are doing some example code, something on the source of the package, you should be able to be the first, have the unit test, but be the first user of your API. So if you're doing that, that should help to reduce the coming back and forth. Because in theory, you already, like the reasons, why is it that we go back? Oh, you forgot to add an input. Oh, you made something optional, it should have been required. Oh, you forgot an extra function, right? If you are doing unit testing at the source of the reusable code, most of the things you are going to find out as you're testing. So that should also reduce the going back and forth. Even with unit tests, you're still going a lot back and forth, then maybe we need to take even a step back and look more at the global design, because there's it sounds like we're doing more code and fix and not really designing, implementing, testing, integrating, right? Yeah,
that's certainly something which I need to improve on. I still have that urge just to crack on and develop. without methodically going through every step I should.
And if you're going back, when you're going back because you found out that you missed something, let's say an input, right? You missed an input and you realize that this has to go all the way to the parent. You're working with classes, and that means going and building back the class and maybe the parent and then the child and everything else. Okay, so again, one of the Dimitri talks about this all the time with the book, the Agile Software Development. I know I have it somewhere in here. Yeah, here. With the solid principles.
Oh, nice. I'll put a link to that in the description.
Yeah, so solid is the set of programming principles that and there's several presentations by Stephen Mercer, Alan Smith, John McLeese, so you can find more within the LabVIEW context. You can have a presentation about it. But there are different solid principles. And one of the things that Stephen Mercer says is that these are like goals that you want to reach to, right? You want to get to them. I don't think it will be possible to implement absolutely all of them. Dimitri might disagree with me. Dimitri Sajidilian, another one that does really great presentations. But there's one. It's the open for close for modification, open for extension. The open close principle, chapter 9, page 99. Okay, the open close principle. So software entities, classes, modules, functions, etc. should be open for extension but closed for modification. So what that means is if you have built your parent into a PPL and you never have to go back and touch it, it is open for extension because you can inherit from it, you can overwrite your methods, so you did a good job. Anytime you're having to come back and open it and rebuild it, you are violating because it's no longer closed for modification. You're having to actually go open it and modify it. Does this mean that you need to, slap yourself and not do it? No. Even if you read on the book, it's going to say sometimes you have to do it. The key here is understanding why you had to do that and fixing the parent in a way that you don't have to do it again. Does that make sense?
Okay,
like you're not gonna be able to see all the things that you don't know right now. But if you open for a particular reason and you're like, oh, wait a second, is this gonna come back and bite me for another reason? Should I be putting other doors or other ways for extending so I don't have to rebuild this thing? So this is another reason why I like to build my dependencies, because it makes me pause. It actually makes you slow down. And where if you have everything in the same code, like you said, you're tempted to just go and start typing and start wiring things and make it work, you're not going to have to take that step back and be like, should I really be doing this, right? So that's one of the advantages that I see, or the silver lining that I see on having to do that context switching, is your opportunity to take a step back and be like, why am I having to do this? What did I miss during the design that I'm having to go back? Or what did I miss in the unit testing that I'm going to have to go back? Yeah. Does that help?
Yeah, that helps massively. Especially as items like patch project libraries, the block diagram is removed, so you can't physically change it without taking a step back, going to the source code, building, and reintroducing to your project.
You could include when you build a PPL, you can include the block diagrams to allow for debugging. So if you are trying to do troubleshooting, you can keep the diagrams, but you are right, you cannot edit them. And that's where working with 2019 makes that better, because you're going to be able, just like you right-click now in a project library and say replace with PPL, you're going to be able to click on a PPL and say replace with project library.
Oh, I wasn't aware of that. That's really cool. Yeah,
that's one of the new features. I haven't used it yet, so I might be still easier, but I believe it's one of the reasons why one of my customers is moving to 2019. So I'm going to be using that for you probably the next week or so. And that was one of the big requests that some of the champions had. It was like, hey, great, but now if I find the bug and I don't want to have to go back and forth to test it, I want to just change it there and see if it works. Now you're going to be able to do that.
Nice. Good to know.
So you have to try it. There's another video for you.
Yes. Thanks. I was just thinking with PPLs as well. PPLs make building your overall executables much faster because they're already pre-compiled piece of code. However, when you go to distribute your executable via an installer, all of your PPLs are distributed with that executable in a data folder, which makes them essentially available to whoever's curious enough to go in there. People like myself. Have you come across any issues in the past with distributing your PPLs in final applications?
Yeah, there's one of our customers actually does an end consumer product. This is actually one of the scary LabVIEW applications that I work with, because when you push the button to deploy, you have hundreds of people, not thousands of people, are going to get a message that says, hey, a new update is available, and then they're going to click and they're going to get it, right?
Yeah.
That's not something that you normally see with LabVIEW applications. LabVIEW applications tend to have a lot less number of users, and most of the time they're technical. In some regards, these particular applications, the end users are not technical. So anything that we might push can be very scary. There's also concerns about intellectual property from the owner of the company. And when we started doing benchmarking projects about how fast was to load the executable we use PPL versus using Project LabVIEW, I mean, it was amazing. It's like, I think you've seen the presentation from Matthias where he shows the graph, and it was just the executable would start right away. But then we realized, okay, hundreds of these people don't have LabVIEW. But it only takes one that has LabVIEW, and they can drag the PPL, put it on their project, and yes, they don't get access to the private VI, they only get the public VI, but they get enough because they get the names of the VIs, they get the names of the outputs, the data types. So that's enough for somebody to start figuring out what the thing's doing. One of the requests that I have asked NI when they ask for feedback is, DLL in other languages, if I don't give you the header file, you have a harder time figuring out what is in there, right? You need to have some sort of documentation or something. Again, the header file. There's not that equivalent in LabVIEW. There's no way of saying, I want this PPL to only be readable by an executable. I don't want you to be able to put it in a project. So that for that particular customer, even though PPL would have been an excellent solution, we use VI package manager for that, and we package and we call the code directly and reveal the executable from the region. Now, we still take advantage of sending things in smaller chunks by having multiple executables. Some of them are LabVIEW, some of them are just dependencies, media player, other stuff the application uses. And we work with Matthias Bodot from StudioBuds, because he has a tool that's called VLT, View License Tracking.
I've been checking that out recently.
Yeah, so I've been using that. Even if my customer doesn't use it for the final application, I use it when I'm working with them, so I can give them multiple iterations. But anyway, VLT doesn't have the facilities yet to be managing different components, so we work with Matthias to create something custom for this particular customer. And that makes it where when the executable runs, it checks VLT like it would normally do and checks for updates. But instead of only checking for updates for the executable we're using, it checks for updates for all the dependencies. And it can check for the version that is currently in the computer versus the one that's on the server. So if it detects that there's a new one, then it pulls that new chunk. So we've been able to have a little bit of the advantages that we would have had if we had gone with PPLs by reducing the chunks that we send when there's an upgrade on the version. But unfortunately, because of intellectual property concerns, we were not able to use the PPLs on the.
Now, I've been, just on the back of that, I've been playing around with two other techniques of, in LabVIEW you can build .NET DLLs and LabVIEW DLLs. Are they something that you've used in the past to try and compress code into?
I personally have not used it. I have advised customers that are trying, and this is I think, did I do that in my presentation? I don't remember. You can do crazy stuff with .NET because you can communicate with LabVIEW with .NET, so you can have actually .NET assemblies built in LabVIEW that are called by LabVIEW.
Well, that's what I'm trying out at the moment.
Yeah. So I've done it where you know how you create the property node for the register for callbacks, and you can right click on it and say you wired what is the thing that you want to register for then, and then you can say create BI, and that creates the BI and all the inputs that you need from your node. So you can do crazy stuff where you can have code that works as if there was an event structure, but there's no event structure to be seen in the block diagram.
Yeah, I think LabVIEW callbacks are one of those things which are super powerful, but not everyone really knows about.
Yes, exactly. And they're normally there for you to communicate with other applications, not with LabVIEW itself. But that's one of the ones where I've seen it. I've never used it, me personally, but I've seen it in other people's code where they get around to having LabVIEW for LabVIEW. And like I said earlier, before we had PPLs, there were the communicating between multiple executables using TCP/IP, building LabVIEW into DLLs, and then calling the DLL that was built in LabVIEW from LabVIEW. So I don't see why these would not work. I think that one of the things that I try to figure out when I'm working with a customer to figure out what is the organization of the code that's going to work better for them is I also look at their team and who's going to be maintaining this and who's going to be working on this. It might be that PPLs is the best solution, just pick one. But if people are struggling with the whole building, and I need, either we need to figure out how to automate it so we can remove that concerns from them, or we need to look for another technique. Same thing with packages, right? It's like packages give you a palette. They work really well for when you have multiple levels of proficiency in a team, and some people want to work with QuickDrop and some people want to work with Palette, but that might also have its own restrictions. So one thing that you need to look at is if you're going to go down this route of using .NET and creating a separate dependency in LabVIEW that is going to be built into a .NET assembly and then going to be called by LabVIEW, who's going to be maintaining this? Who's going to be using this later? How can you document it so when you onboard someone, they don't get completely, because this is going to be something scary. It's probably going to be very clever. It's probably going to work great. Can you grab someone out of the street that has a PLD or a CLAP and you seek them and say, read this documentation and figure out what I did, then it's going to work. If you cannot do that, then it's not going to work. One of the things that we do at Delacor when we onboard someone is we use them as guinea pigs, in a sense, right? They get to work on a project, they get to test DQMH, they get to do some things where we don't give much information, we just make sure they have the README file on the repository, and they have some general instructions. And then we see how they do. And their first project is to create Jira cases, that's what we use, on where they got stuck and how that could be improved to the next person. So every time we onboard someone new, our process improves because we get someone with fresh eyes, we know tainted experience, well, they might have their own, and then they tell us, okay, I was expecting this or whatever. And it's when you do exercises like that, and I have done that with my customers too, it's when we decide, yes, this might be a very good solution technically, but it's not a sustainable solution if we're having to spend, a whole week onboarding someone just to do one task, and then they might forget about it in 2 months. So those are the things to keep in mind too. Is who is going to be supporting maintaining this? What are the tools that you can give them to make it better? The reason DQMH has a scripting is because user events was something that I could explain it, people would understand it, but we still would get calls every time they wanted to create a new event. So that was like screaming at us. Yeah, user events might be powerful, but not everybody can use that, right? We need either to change to a different method or provide a tool so they can figure out on their own. And that's how scripting was born.
Yeah, absolutely. And it's one of those things which I need to remember as well, because all of my projects are usually Active Framework, which I find for me as a solo developer. However, at some point, I'm going to be leaving Scientifica. I'm going off to do my own thing, perhaps. The next person who comes in perhaps isn't an Active Framework fan and wants to do something else. I was just looking at some of your videos on YouTube, Fab, about DQMH, and have realised that there are lots of modules which would, in my project, that would be much better suited to DQMH modules, and some which are best suited to Active Framework modules. How easy would it be to mix and map DQMH and AF modules in the same project?
So, Ollie Wagner did a blog post at the Delacor blog about a year or 2 years ago, where he did an experiment on what would happen if you wrapped an actor with a DQMH or something different. He was actually using the scripting user events library that you can download from our website. So it's kind of DQMH-like, but it's not exactly DQMH. And he tried that. In my experience, DQMH was created with user events. One of the reasons why we use user events is that if you don't register for user events, you can be firing user events all day long and they don't create a memory leak because there's nobody registered to listen to them, right? So they don't enqueue anywhere. When you use queues, you need to have a DQ. So our framework, and this is something I think Sam Taggart says on his presentation on frameworks, is actor framework is contagious. You create an actor, and because you need to create the queue, right, to have someone launch that actor, the temptation starts to be that the launcher becomes an actor as well, and then later on that launcher becomes an actor as well, and when you come back, you were intending to have a single actor, and you come back and 2-3 months later, and you have this chain of actors, because it kind of made sense to do the launching so you could have the bidirectional communication, and you get into your tree control and all that stuff, right? DQMH, the modules are standalone. That you can actually run the main VI of a DQMH on its own, and it should still work. Or they can be called by something else, the API tester or calling code. And the idea came from me working with enough customers that had what I call China cabinet block diagrams, where if you move something, things like literally move a wire and things break. So I would, when they would ask me for new features, I wanted to give them something where the new feature could stand on its own and have a tester. So if I give you the tester, you can exercise everything you need. Now you go and put it on your China cabinet, whatever you see fit. You know that architecture. I don't know that architecture. I don't want to break it, but I can give you the feature you need. That also helped me when they would come back and say, hey, things are not working. I would be like, can you reproduce it on the tester? If you can reproduce it on the tester, the bug is on this end. If you cannot reproduce it on the tester, the bug is on the architecture. It's on the China cabinet, right? There's something they're pushing. And that was excellent. And that's actually one of the things that why I push so hard to have API testers on DQMH, and why when you use the scripting on DQMH, the API tester comes on your face and it's the first thing that's like, how are you going to test it? And it's that idea. So yes, you can definitely call DQMH modules any calling code. After framework you can, you just need to make sure you have something that prevents you from starting into this crazy thing where you start creating actors that are you just creating just because you're using an actor. One other thing that DQMH you can do that people have done is on hardware abstraction layers, and this is kind of where Ollie was going. It's like, well, if I already have an actor framework that does the thing, but I want to abstract or hide all the actor framework things, you can use the DQMH as the scaffolding that provides you an input for people that might have a lower level of proficiency. Then they can use the API and use the tester. Other use for DQMH modules in an OO architecture is just because of the scripting, you can create a harness to test your class pretty quickly and have an API tester and a UI. So some people use DQMH just for that. Michael Howard need to upload the video. I have to get the time to edit it, which was very good, where he did a hardware abstraction layer for DQMH. And he showed how they do it, where they have a parent class and all their API testers look the same for all their instruments. So whenever they're doing classes, they're using DQMH to wrap the classes just so they have that familiar interface for the different developers in the company that might not be enthusiasts. It doesn't matter. All they want is to get the job done. They can run the API tester and do it that way. So anyway, short answer, I can never give a short answer. But the short answer is yes, you can mix and match. You can definitely do that.
Nice. And it's the actor testers, or we call them the VI testers, which I'm most interested by in DQMH. I believe it was Sam Taggart created an actor tester for AF. I'm yet to download that and try that out myself. Integration testing and module testing is something which I still need to get on board with and actively do. I know I should do it, but
I think if you start doing more of that, some of that context switching that you were complaining about earlier is going to reduce a lot, because you would be exercising the API before you are building it and integrating it with something else. And it takes, unit testing, test-driven development already requires the paradigm change, right? It's the, let me figure out how many testing things, implement the test first, then do the code that fixes it. I think that's the ultimate. If you get there, you'll see why the people that do it, we don't want to go back. Having the API tester is kind of an in-between. Because you're still not doing some automatic, unit testing, and you're really just doing a button that's going to launch the module to do what you're expecting it to do.
Yeah.
But it already starts getting you in that direction of how am I going to test it? How am I going to be convinced that I have implemented that feature? And you have a way to manually come back and try it out. So the API tester is more like an integration test, not a unit test level. I mean, it can be automated later into unit test if you want, but that's the idea. One of the things to look into is when you play with Sam Taggart's, which are great. He basically took inspiration on the DQMH API tester and then said, how can I do this? And he has been creating other tools from what he has learned from DQMH and applying them to Actor Framework, like the templates, the Actor templates. That comes from DQMH having templates where you can create your own template. You don't have to use the singleton and the callable. You can create your own templates that have, there's Bella, I think, he created a template that looks more like a JPI machine. So you can still use all the scripting tools for DQMH, but have your own structure that you find. So he used that too. But one of the things to look at when you're looking at the testers that Sam did is the hardness. When you look at the API tester for DQMH, it shows you how lightweight it can be. It's a while loop with an event structure, you're done. When you look at the API tester for an actor, the hardness is a little bit more complex because you have to do the whole thing about creating the queue, handling the queue, and all that management. And again, I'm not saying that Actor Framework is bad. I think Actor Framework is a very good architecture. I think it has a lot of safeguards in place that if you are comfortable with object-oriented programming, you're an architect, that you do LabVIEW 100% of the time, go for Actor Framework, definitely. DQMH was thought more on teams of different levels of proficiency. We have a lot of customers that LabVIEW is just a tool. They don't breathe LabVIEW every day, right? If they use it maybe 1 month out of the year, they need to come back to a project and be able to find out where they're going to. So when you look at that, that will give you an idea of what is it that I need to add to calling code that is not DQMH or to calling code that is not Actor Framework in order to call this code. And you'll see the difference. The Actor Framework moves a lot of pushes a lot of the complexity away, but then adds it on the calling code if the calling code is not Actor, right? So
Okay. One last thing I wanted to touch on was sub-repositories or submodules. So in your source code management, you can have your main project source code. Even you can add on submodules to your different repositories. What process would you recommend for creating your submodules, and when would you use submodules instead of just putting everything into your main project repository?
So one of the things that I really like about submodules is I am a firm believer that if you're going to be doing packages or PPLs, you want to have a project per PPL or a project per package, right? You don't want to have, you could have a project with multiple things that are going to be going into a package, but the chance, the opportunity for you to be calling source code instead of the release code becomes greater if you're mixing, right? So I am a firm believer in having a project per release code, like I said earlier. The best way to manage that is to have a repository, because then you can then share that to other projects. One of the customer that was telling you that has a huge application, one of the reasons of having the multiple module portfolio well for him is he's worried about the intellectual property. He can hire contractors and just give them access to the submodule that they need to work on. And he doesn't need to give them access to everything, right? So that's another nice thing about separating into submodules. So having the submodules, what makes it really nice is I can have a project that has a single top-level project, right? And it's depending on multiple packages and multiple PP files. So I can have a VIPC file. A VIPC file is a configuration file that tells you which versions of your packages you're using. Or I can have some sort of list or something that tells this is what you need these are the versions that you need to be using. And have on the same project access to the source code that generated those files. Make sense? So if I have a customer, for example, right now that we are doing PPLs for different devices that they have on the test, we have the main project that when you open that project, it doesn't load any of the classes in memory. Everything is built into PPLs, right? But if you realizes later or when they were working on it that they want to add a new feature, in the same repository, by virtue of pulling that repository, they can go to the submodule that has the source code for that PPL, and that has the README that says how to build that PPL, and that has the automated process to build it. And the main application has the field specification to creating the installer that's going to be putting the PPL, grabbing it from the right place, right? So submodules allow you to document or put in a nice box everything that is used to create this application. The VIPC or the list of PPLs gets you going, but doesn't give you maintenance tools for later on, right? We still need to go hunting down where they're at. Submodules tells you here is where the source code for that PPL that you're using is. You probably don't need it. Hopefully we did a good job and you don't have to ever touch it again, right? But if you were to touch it again, this is where it's at. So that's where I find organizing, and this is the example that I used on that blog post I pointed to. Even for the example I uses packages, for the example I uses PPL, I still use the submodules and they're still packaged on an ad repository, so you could see what I would be giving you to see, okay, you're using on these top-level applications PPL, but here's how you create them.
Nice. So a bit of a take-home message then. You would typically have a repository which you create into a sub-repository for each library module that you're creating into a packed project tree, and that allows you to document all of your different modules, bring them into the project you're creating, and that main project you would then have a build specification for your executable, which points towards all of your PPLs. You mentioned about VIPCs. Am I right in saying that VIPCs are only available in the Pro version of VIPL?
So, okay, there's two things. Right over the VIPC, let me just clarify one point that you mentioned earlier. a library or collection of libraries that work together.
Okay.
Right? So, for example, we have a configuration editor in DQMH that the editor itself, it looks like the options window in LabVIEW, right? You have a list of categories and then a sub-panel where you insert things. So there are two main DQMH modules for our configuration editor. A singleton, which is the editor, and a clonable, which is the page that manages the inserting of the sub-panels. Those two things will always live together. Doesn't make sense to have a separate repository for one library and a separate repository for the other one. Those two libraries will always be called together, so they're on the same project, they are packaged into the same PPL, or they are packaged into the same PPL package. So I just want to clarify that, because I don't want people saying, hey, Fabiola said that I needed to have a project library for repository. So it's more of a unit of work, or what is that going to be building together and creating into a single API. So it's two libraries, but at the end of the day, the end user only sees one page, one UI, and the developer only sees the API for the editor itself. They don't see the behind the scenes of the other modules that ends up being support behind. All right, VIPC files. Yes, VIPC files can only be created with the professional version of the JKI DQMH. However, you can apply VIPC files with the free version.
Okay.
So, yeah. So, the ideal would be if JKI had site licenses where it would make sense for people. If you have multiple developers, it's just better to have a repository for the company because they can register for it, they can see when there are new packages available. It streamlines things a lot nicer. If you, for whatever reason, don't have the budget on your company or just not get to negotiate a good deal with JKI for site license, what people have done, and I believe this is within license, I guess if somebody from JKI sees this and they don't agree, they will let me know, is they put the build server has the professional version of the API. You need it so you can add things to your, you can build packages with the free version. But if you want to add certain things like add password protection, add prefixes, add more documents,
and use the command line interface for building packages.
Yeah, so if you want to do any of that stuff, you need the professional version. So you're going to have it anyway on the field server. So what I've seen people do is they have the professional version of the field server, and then that's where they go and create the DIPC file. Because it's part of creating a field release, right? It's building, and that's actually automated too, because you can scan the repository. You could have an actual repository there that is for your company on the build server, publish your packages there, grab them from there, do all that thing, and then create the VIPC files. And the rest of the company would just apply them. VIPC files can have the package included as part of the VIPC, or by value, or you can have it by reference. Okay. You can just have a pointer to the package. So when everybody in the company has the pro version, you can have, in your company, Scientifica could have Scientifica repo, and then you could create your VIPC files only pointing to it instead of storing it within the VIPC. That makes your VIPC file very small, which is good for source code store. And because everyone else would have access to it, then they could just say apply. It would go to the Scientifica server, get the right package and install it. If you don't have everyone using the pro version, then you can still build the VIPC. You make sure you store the package within the VIPC, and then anybody else that has the free version can apply it. So that would be the workaround for that.
Perfect. That's really good to know.
Yeah. And it really, at the end, I think people have to manage their productivity and figure out if this is a good enough workaround. I feel like everybody having pro, and again, I don't get any feedbacks from GKI, those facilitate a lot more the working with reducible code. But if you don't have the budget, or you have to have enough arrows on your back to show to management that you actually did, a good workaround is just to have it on the field server.
Okay. Thanks, Fab. I feel we're fastly running out of time here. So I'll go through this recording and put lots of reference material down in the description. I'll put some links to the DQMH tutorials and where people can download them. Any final thoughts from you, Fab?
Well, I hope this help you out. I think, I think the main thing that I got from talking to you is this testing, right? If you are having a better approach to design and testing the individual parts, the going back and forth changing context should be reduced. If not to zero, because we don't know what we don't know. Hopefully help you to not having to be switching back and forth. And the other thing is seeing the switching back and forth instead of as a burden, as a blessing, and let's take a step back and figure out why am I having to do this? And the answer can be yes, I have to do this, but it's giving you the opportunity to take a step back and actually think things through.
Cheers. Yeah, that was definitely one of my take-homes as well. All right. Well, thanks very much for your time, Fabiola.
No, thank you for setting this up. And if you need anything else, or once you start figuring out how to prepare for onboarding someone else, let me know. We can see how we can help you.
Cheers. Well, thanks very much, Fab.
No problem.
See you at next conference. Bye.
All right.